Now in the previous lecture, we have created our circular queue class over here and we have implemented 4 methods. So the first method was creating circular queue, then we have implemented is empty method, then is full method, then enqueue method. Now in this lecture, we are going to implement 4 methods over here. So we are going to implement dequeue method, pick method, and delete method. Now here, after enqueue method, I'm going to declare dequeue method like this. Now we know that in case of queue, the queue method has to return the first element from the queue and it has to remove the first element from the queue over here. Now that's why I'm going to declare our dequeue method with the return type of integer. So it's going to be public int dequeue. So as a parameter, it's not going to take any parameters. So we are going to implement our method like this. So the first thing that we are going to do, we are going to check that if queue is empty or not. So if it is empty, we are going to return to the console saying that the queue is empty and we are going to return -1. So if it's empty, then in this case we are returning to the console saying that the queue is empty, the circular queue is empty, and we are returning as a return type -1. So when we receive -1 from the dequeue method over here, it means that our queue is empty. So we cannot dequeue any element from the queue over here. Now in the else condition, we are going to implement the logic which is for circular queue. So the first thing that we are going to do over here, we have to create a variable and in which we will keep the value that we are going to remove from the queue. So I'm going to declare integer result. This will be the value of cell which is located at the beginning of queue in this case. So in this case, it's going to be like this, beginning of queue, because this value will be removed from the queue over here. So at the end, we need to return it. So that's why I'm going to save it to the result variable over here from the beginning. Then we are going to set the value of this cell to 0 in this case. So if I set it to 0, it means that this cell is empty and this cell is unused. So you can set this value to any value that you want. So in this case, just for simplicity, I am setting it to 0, but normally people are setting to the minimum integer value or whatever integer value you want. So in this case, I'm going to set it to 0. So this value depends on your choice of implementation. So here for simplicity, I'm setting it to 0. Then the first if condition that we are going to check, if this is the element that we are enqueuing from the queue is the only element in our queue. So if this only element, in this case, we are setting the top of queue and the beginning of queue to -1, because after enqueuing this element, the queue becomes empty. So to check that, we are going to do it like this. If beginning of queue is equal to top of queue, in this case, it means that we have only one element in our queue. So this means that I'm going to set beginning of queue and the top of queue to -1, because after dequeuing this is going to be empty. So we know that if our queue is empty, so beginning of queue and the top of queue has to point to -1 over here. Now in the else if condition, we are going to write another condition. So if the beginning of queue has reached end of the array, then beginning of queue will start from the first cell of array. So in this case, beginning of queue has to set to the 0. Otherwise, we are increasing the beginning of queue in each the queue operation over here. So it's going to be like this. Else if beginning of queue plus 1 is equal to the size of the queue over here. So in this case, it means that beginning of queue points to the last cell in the array. So this means that after dequeuing an element, the beginning of queue has to point to the first cell in the array. So the first cell's index is 0. So that's why the beginning of queue will be set to 0 over here. Now then in the else condition, we know that when we are dequeuing the element from the queue, we are just increasing the beginning of queue in case of array over here. So I'm going to increase it by 1 in this case. Now at the end, we are going to return this result value that we have over here. So I'm going to put return result. So with this, we have successfully implemented the queue method in case of the circular queue. So what we are doing over here is, first we are checking that if this queue is empty, so this means that we cannot remove any element from this queue. So we are going to return that the queue is empty and we are going to return -1. Then otherwise, we have two conditions over here. So the first condition is if we have only one element in our queue. So in this case, after removing beginning of queue and top of queue has to point to -1. So we are setting them to -1. Otherwise, we are checking that if the beginning of queue points to the last cell in our array, it means that beginning of queue after dequeuing will be set to the first cell in the array. So the first cell's index is 0. So we have to set it to 0. Otherwise, in all other cases, we are going to increase the beginning of queue by 1. Now this is how Dequeue method works in case of circular queue. Now let's see how this is working in practice. So here, as you remember, we have created a circular queue like this, and we have inserted 3 elements to the circular queue over here. Now for the 4th element, instead of calling enqueue method, I'm going to call Dequeue method. So I'm going to save it to some variable over here. So I'm going to put integer result. It's going to be Dequeue. Now we know that the first element in our queue is 10, so if we call the queue method, it has to return this 10, and 10 has to be removed from the queue over here. So I'm going to print out to the console this result value to see how this is working. Now let's run our code to see how this is working. Now here you see that first the queue is created, then we have inserted 3 elements to the queue, then when we are calling the queue method, it's dequeuing the 10. So 10 is the first element in our queue over here. Now if I call, for example, the queue method one more time, it's going to, in this case, return 20, because in this case 20 is the second element in our queue. So after dequeuing 10, 20 becomes first element in our queue. So if you run our code, you'll see that first it's returning 10, then it's returning 20. So this means that after removing 10, 20 becomes the first element in our queue over here. So here we see that our method works successfully, so we have implemented it successfully. Now let's see what's the time and space complexity for the queue method over here. Now here, as always, we are going to start from the first line of this method. So in the first line, we are checking that if this queue is empty, then we are returning message to the console, and we are returning -1. So these 3 lines of code will take a 1-time complexity. Then in the else condition, we are creating a variable over here and setting the beginning of queue to this result variable. So this will take a 1-time complexity. Then we are setting the beginning of queue cell value to the 0, and this one also will take a 1-time complexity. Then in the if condition, we are checking that if the beginning of queue is equal to top of queue, so then we are setting both of them to -1, so this part also will take a 1-time complexity. Then in the else if condition, we are checking beginning of queue plus 1 is equal to size, so this part also will take a 1-time complexity. Then we are setting the beginning of queue 0, and we are increasing the beginning of queue by 1 in the else condition, so this part also will take a 1-time complexity. Now at the end, we are returning result to the console, so this will also take a 1-time complexity. Now if we combine all these complexities over here, we get a 1-time complexity. Now the space complexity is also O1, because in this case an extra space is not required to perform these operations over here. We are just performing returning message and updating the variables over here. So this is not space consuming operation. Now, so that's why the space complexity is O1. Now with this, we have successfully implemented the queue method. Now the next method that we are going to implement is pick method. Now we know that pick method returns the first element from the queue without removing it. But in case of Dequeue method, we are returning the first element from the queue, then we are removing that element from the queue. But in case of pick method, we are just returning the first element from the queue. So in this case, we are not removing the element from the queue, because in some situations in our applications, there might be a situation that we are just checking the beginning of queue. So we don't need to remove it. So in this case, pick method is very useful. So here I'm going to declare our pick method like this. So this method will return the type of integer, because the elements in our queue in this case are integer. So then the first thing that I'm going to check, if this is empty, it means that we are going to return to the console saying that the queue is empty, and we are going to return -1. Otherwise, we are going to return the first element from the queue over here. So the first condition will be like this: is empty, then we are printing out to the console saying that the circular queue is empty. Then after this message, we are going to return -1. So in this case, it means that our queue is empty. Otherwise, we are going to return the first element from this queue over here. So we know that first element is located at the index of the beginning of the queue. So if we access the array with the index of the beginning of queue, in this case, we are accessing the first element in this queue over here. So with this, we have completed our pick method. So basically what we are doing over here is we are just checking that if this queue is empty, we are returning -1. Otherwise, we are returning the first element from this queue over here. Now let's see how this is working in practice. So before we have created a circular queue like this, then we have inserted 3 elements. Then we were checking the queue method. Now instead of the queue method, I'm going to call pick method over here twice. Now you will see that in case of the queue method, first it was returning 10, then it was returning 20. But in this case, for both returns, it's going to return 10, because we are not removing the first element in case of pick method. Now here you see that if we call pick method twice, it's going to return 10 for both cases, because we are not removing the first element from this queue over here. Now from here we can easily see that we have successfully implemented pick method. Now let's see what's the time and space complexity for this method over here. Now it's obvious that the time complexity will be O1 because here the first if condition is checking that if this queue is empty, so this will take O1 time complexity. Then we are returning message this queue is empty and we are returning -1. So these two lines of code will take O1 time complexity. Then at the end we are returning a cell value from this array, and we know that by using index to access any cell in the array takes O1 time complexity, so this line of code will take O1 time complexity. Now if you combine all these complexities over here, we get O1 time complexity. Now it's obvious that the space complexity is also O1 because in this case an extra space is not required to perform this operation over here. Now let's continue to the next method. So the next method is delete queue method. So in case of queue, when we are calling delete method, it's deleting the queue from the memory. Now in this case, in case of array, when we are creating a queue, we are declaring an array in the memory. So if we remove this array from the memory, it means that our queue will successfully delete it from the memory. So our method will be like this: public void delete queue. So this method will not take any parameters. So here all we are going to do, we are going to set this array that we have declared to null, and then we are printing out to the console saying that the queue successfully deleted. Now with this, we have successfully deleted circular queue from the memory. Now let's see how this is working in practice. So for instead of pick method over here, if I call just delete method for this queue over here, it's going to delete that queue from the memory. Now if I run this code, you will see that it says that the queue successfully deleted from the memory. Now you see that the circular queue is successfully deleted. So our delete method works successfully. Now let's look at what's the time and space complexity for this method over here. So it's obvious that the time complexity is O1 because these two lines of code takes O1 time complexity, and the space complexity is also O1 because here we are just setting the array to null and deleting the all elements from the memory. So this means that it will take O1 space complexity. Now with this we have come to the end of this lecture. So in this lecture we have implemented three methods of the circular queue, which are delete queue, dequeue elements from the circular queue, and pick method. So hopefully everything is clear about these methods over here. So see you in the next lecture.